slide deck that I have on. Oh, okay. Tell me when they do show. Okay, start sharing, and I will start sharing again. I'll be presenting to everyone. Okay, so it's working. Let me go back to the screen. I hope that's what it means. Okay. Okay, so I will continue. I can't hear you guys, so why can't I see it? The other class I could see it. Okay, so here we go. So I don't see you. If anybody can talk to me, then they can tell me to stop. Otherwise, I'm just gonna keep going through this. Okay. So thank you guys for having me join your class to talk a little bit about oncology, immuno-oncology. So I work at Eli Lilly, and I'll tell you a little bit about myself first, but I must mention that what I'm working on is immunology, and it's sort of a combination of two different types of science, let's say, immunology and oncology. Immunology is sort of how your immune system in your body fights foreign particles that attack you. Oncology is the field of cancer, studying cancer. So putting those two together, combining your body's ability to fight using its immune system, and in terms of cancer, the body's immune system fighting cancer. So that's what we're working on. So a little bit about myself. I'm from Sri Lanka. I came to the US when I was 14 years old. I put a map of Sri Lanka here because most people would know where India is, but Sri Lanka is not so well known. So it's a small little island off the coast of India, its own country. So I came here at 14 and I started high school as soon as I came to the US, which was quite hard. After I went to college and grad school in San Diego. So during my last year in college, I did a study abroad program in France for about a year, and I studied French, and I'm fluent in that. And I'm sort of fluent in Spanish because I lived in San Diego and everything's in English and Spanish there. Came back to California from France and then decided to do graduate work in biology because first when I was in college I was a little bit burnt out from biology, but after the break in France I got excited about biology again. So then I started to work. First job was at the NIH, and most of you guys must have heard of the NIH. It's in the news all the time. A big research institute in Washington, D.C. I lived there for about 2 years and studied and worked there. After that, I moved to New York City, and I worked in the company called Sharing Plow Research Institute. So NIH is a government-based institute, and Sharing Plow is a private pharmaceutical company. And now they are part of Merck. So Merck is a big company that most people have heard of. After that, I moved to another smaller company called Inclone Systems, and that was based in New York City. And from there, Eli Lilly, which is a big pharmaceutical company, bought the small biotech company, so I'm part of Eli Lilly, and I've been working here for about 10 years. And so I went from that little country in Sri Lanka to this big city, New York City, Manhattan, and I love living here. So my degrees are in microbiology and molecular biology, but now I work in immunology, and it's a completely new field, completely different, very complicated, and another job. Beverly asked me what is exciting about immunology for me and what I have learned here. I'm still learning. Immunology, what was really exciting is that you can use your immune system in your body, which is natural, you think, to fight for particles, but cancer is kind of an unusual thing. So it's fascinating to me that we can harness our immune system to fight off cancers. It doesn't always work, but it's one of the ways that we're trying to help cure cancer. That's possible. I'm going to move on to the cancer stuff. So I can't hear anybody, but if you have questions, please somehow stop me. Maybe a chat will pop up if you have a question. So I'm going to go through some slides covering what is cancer and how do people get cancer. And these are just very basic information. There's much more if you delve into each topic in detail. There's just so much more, but I'm just going to cover a very broad range. And then how to treat cancer. Most people know about surgery, radiation, and chemotherapy. Those are sort of the first line treatments that they have. And then talk about new ways of treating cancer and oncology that I'm working in. And it's a very high impact, very interesting field. Everybody's working on it. So hopefully that means that there's a better opportunity for patients finding treatments. So how do people get cancer? The first easiest thing to mention is genetics. It's not always the case, but most people, you're born with the genes that your parents transfer over to you. So this little schematic, I'm not at genetics or it talked about how parents can pass on genes to you, but here it's showing a father and a mother. And when they have kids, each of the children will have one chromosome from the mother and one chromosome from the father. So in this image, if the father carries a mutation, and let's say this mutation may cause cancer, some of the kids will have that mutation in their genes. And if these children get this mutation, they might get cancer. but it's not definite. It's just saying that they're carrying this gene. So genetics is one way, and you can't really avoid that. The genetics is passed on from your parents. So that's why when you go to doctors, sometimes they ask you if your parents have had cancer in their family, if the grandparents have had cancer in the family. So those questions come because of genetic predispositions. Another well-known way of getting cancer is behavioral and environmental trigger. So you must have heard about people saying eat right, eat well to prevent cancer. So that's one good thing. Just doing that is not going to change anything, but that's one of the steps that you need to take in terms of keeping a healthy body so that your body's immune system and your body's normal system can fight off abnormalities, not just cancer. Environmental triggers. So behavioral cigarettes are known to increase risk of lung cancer. There's many studies that have done to show that. So if you smoke, there is a chance of you being more prone to get lung cancer. Doesn't mean you'll get it, but there's a higher chance of you getting it than a person that doesn't smoke. Too much exposure to the sun. This is something that we all have. Summertime, people sunbathe. If you don't wear sunblock, this could be lead to skin cancers. And air pollution may be associated with lung cancer. Lung cancer. And this is, there's some areas that have high pollution levels. Some cities, Los Angeles has a lot of smog. So people who are exposed to that could also develop certain cancers. And these are all triggers that can lead to your body's cells reacting to the trigger and then developing into a cancer. So what is cancer? So there's not one type of cancer. There's many diseases that are known collectively as cancer. So basically what cancer is, in the top picture here, is showing that it's the loss of normal growth control. So basically in normal cell division, have one cell that divides, becomes two cells, and each cell again divides, becomes two cells. Within all these cell divisions, there could be some problem that happens and the cell itself becomes a little bit abnormal. What your normal body can do, a normal functioning body can do, is fix that damage and make that cell either die so that it doesn't propagate or become more and more of these ugly, bad cells, and only the good cells survive. But then if you don't have a way of getting rid of this bad cell, what happens is the bad cell becomes multiplies. And that's what's shown in the bottom. So cancer cells grow and multiply in an uncontrolled manner and form tumors or something like this. So basically what happens is the bad cell growing takes over the good cell growing in a good the normal way, so the uncontrolled growth of these tumors and then can disrupt your normal body's processes. So that's how cancer can occur. But again, these type of cells could be, you have many cells in your body. So all of these cells have the ability to become a cancer cell. And it's amazing that they don't all become cancer cells because your body is able to control these growth of cells in an amazing way, so that doesn't happen. But still, some things will escape and cause a tumor. And this escape can happen from what I just mentioned before, genetics and other behavioral and environmental triggers. So how do we treat cancer? The most common known ways are listed here. So we have surgery, radiation, and chemotherapy. So if a patient goes to a doctor and they discover cancer, one of the first things they do is, if the cancer is big enough, they're able to do surgery and remove all the tissues. So when the surgeon removes the tissues, they try to remove everything so that nothing is left behind. But if something is left behind, there's a problem. That cancer, that cell or cells that get left behind can then now start to grow again. And so even after surgery, cancers can come back. So surgeons tend to take out the cancer that they can detect in addition to some extra around the cancer cell. So surgery is a good way, but again, some cancers, it's not that easy to do. When that's not possible, radiation is something else that's done, and sometimes it's done in combination with surgery. So radiation, basically, they use a machine to target the cancer cells in the body. They aim cells. They kill the cancer cell by targeting it with radio waves, X-rays. And that again can kill the cancer cell, but what happens is any cells around it are also going to be killed. So those any cells around it, I mean normal healthy cells. So you can see how killing a cancer cell, you're also damaging other parts of the normal good cells. So that could, people coming from radiotherapy, there's cancers that are killed, but this will have side effects, a little bit of sickness because their normal cells are now affected as well. Chemotherapy is another one similar to this, where now you take a medication and you can get it through IV or a pill. And either way, what happens is that the cells are targeted by the chemotherapy in a specific way. And I don't want to get into it in too detail, but it's targeted in a very specific way so that the cancer cells are killed. But again, in addition to cancer cells, your normal cells can be killed as well. And this is when cancer patients who go through chemotherapy, you get a lot of people who lose hair. So a lot of cells that are rapidly dividing are the ones that are targeted by these chemotherapy. So you can imagine your hair grows really fast, right? So they're rapidly dividing. So chemotherapies can be in addition to targeting the rapidly dividing cancer cell, it could be also targeting your normal hair cells. So now your hairs start to fall out. So those are some of the side effects from chemotherapy. So because of this, scientists and doctors want to find better ways to treat cancer. These are all possible. These are still all being used. But what can we do better to help the patient get rid of the cancer, but also have less side effects? It's not a perfect system, but that's one of the targets. So the top part of this image is showing the traditional cancer therapy. So I mentioned radiation, chemotherapy, and surgery, but here we're just talking about a drug. So it kills healthy cells and cancer cells, and you have many side effects, which were mentioned in the slide before. In the bottom section, I'm listing cancer immunotherapies, and that's what I work now. Basically, what it is you're trying to target the cancer cells specifically and not try to kill any of your normal cells. That is the final goal. So immunotherapy has many different methods. One is mainly it's using your immune system. So you might have heard of, or you haven't, but there was maybe 3-4 years ago, there was a baby that had leukemia. And she's still in remission. Actually, there were 2 kids. One of them, for sure, is still in remission. And basically what they did was they took immune cells that were healthy. They engineered it, so they did something to it so that it can detect the cancer that is in this baby's body. Okay? So they modified those immune cells. So again, immune cells, there's many cells, but specifically T cells. That's, maybe you'll learn that in class. So T cells, they modified it specifically so that it would detect the cancer in the baby's body. That means that cancer is also having a lot of these okay, I won't get into it too much. This is too complicated. So detect the cancer in the babies. They injected the baby with these T cells that could detect the cancer. And what it did was the T cells went in the body and killed those cancer cells. Now, in addition to that, what happened was the baby got really, really sick first. She had a fever, and they thought they were going to lose her. But what happened was, after a slow period of that really bad like symptoms, she picked back up, and now she's healthy. What happened was that when the modified immune cells were put into the baby's body, it took a while for the cells to really find the actual cancer to kill. It was sort of, looking at other cells in the body, maybe targeting, killing, and the baby was just having a response to a foreign particle in its body. That wasn't the cancer, that was the treatment. But it picked up. So doctors found out that this type of therapy has a really harsh symptoms in the beginning, but if the baby can survive, or the patient can survive, it will start to respond and respond well. So this is for leukemia that was treated. Now, I mentioned there are many types of cancers, so not all cancers can be treated that way. So every cancer needs to be looked at separately, see what is going on in the body, and then be able to treat it. So this was just one anecdote of a specific type of immunotherapy. Because I work in a private company, I can't talk about specific targets that we work on, specific drugs, but basically everybody in immunotherapy, immuno-oncology, works on this idea of using the immune system to kill cancer cells. So this image here, so the immune system to kill cancer cells is most of the words that come out, most of the keywords that people talk about are checkpoint inhibition. So what I put here were two scientists who were working since James Ellison worked since 1977, and Dr. Honjo worked since 1992 on specific targets that are now being used by many people to develop drugs to cure cancer. So they just won the Nobel Prize last year for their discovery. And as you can imagine, they waited a long time to win a Nobel Prize, but obviously they didn't do the work to win the Nobel Prize. But these guys are considered rock stars in our field now, that they're scientists because of what they are. So what they basically did was, if you imagine a car, and this is what checkpoint inhibition means. If you imagine a car, you're normally driving it. If you, the immune system is usually, in a normal system, you're driving at a normal speed. When you have something, let's see, there's something, a foreign particle that's attacking your system, your immune system starts to ramp up to be able to kill that foreign particle. So it's like pressing the gas pedal. The immune system is going. At some point, you need to slow down. Otherwise, too much activation of the immune system will be bad for your body. You'll have almost anti-inflammatory response, like something where the immune system is attacking everything in your body. Some people have hay fever. Hay fever is an over attack of the system of your normal body functions. So too much gas, your immune system starts to overreact. So you need to slow it down. So your body, your immune system, hits the brakes. So when the brakes are hit, the immune system slows down. So now in cancer, what happens is, because your normal cells in your body are the ones that change and all of a sudden become these bad cells, the immune system doesn't necessarily realize that that's a bad cell, because it still has some characteristics of your own cells. So it thinks that everything is normal, so it hits the brakes. But what happens with the drugs that we're trying to use to harness the immune system is we're trying to take the brakes off the immune system, so that now the immune system will recognize those normal/abnormal cells in your body as bad and start to kill. So, and even that, you can imagine, if we take the brakes off for too long, now the immune system will again go haywire, and you would have a bad body again. So it's a matter of giving the drugs at the right time, for the right amount of time, and not creating other toxicities. I hope that was clear. So that's all I wanted to say about immunotherapy. And then I just want to leave with these challenges, and maybe you can have some questions for me specifically. So I hope I clarified that there are many types of cancers, and so one cure may not be possible, but many cures are possible, and there's some cancers that have been cured. Leukemia is one of them. And again, it depends on when you discover it. If you are able to get detected early, treatment is good, but not all cancers can be detected early, so there's some caveats there. Then, even after you develop a medication, there can be resistance to medication that occurs. So you need to develop a new way to treat the same cancer. So cancers, we say they're smart. They're these cells, they get killed, but then there's one cell that will survive somehow because it's found a way to take the drug, the treatment. So then that can now develop, but now it has the resistance to the drug that was given. So now you need to find a different drug to kill it. So that's why sometimes cancers are not always cured, or they come back and you have to have another treatment to cure it. So combinations are needed sometimes. And I wanted to leave with the question, what challenges you can think of that might be roadblocks to getting to a final a cure to any of the cancers that are out there. So that's all I have. Let's go back. I'm going to stop presenting. And you guys have questions? Take them. How did I become interested in my research? Okay. So, like I said, I wasn't in oncology and I was not in immunology. I was more interested in science. When I started, I was interested in microbiology. So I was interested in, I worked on salmonella, and salmonella is one of the things that people get sick from when they eat bad chicken. It's a bacteria. So I was interested in that. I was just interested in the science. When I came to industry, so private industry, it turned out that in academia, you study how just the characteristics of something, just to understand how something works. In government institution or private institution, you have to do something that is beneficial to the outside world, not just to yourself. Okay? So most companies work on diseases. So I became interested in this research because of the company I worked in. I started in a company that was focused on oncology. So I became interested in that. I always wanted to work in cancer, but it's really hard to do that in academia. So in academia, in order to have a result where you see patients being helped right away. So I became interested in cancer just as wanting to cure it, but then became more interested in working at the company. But also, my grandmother had cervical cancer, and they didn't discover it until it was very late in her life. And so from then on, I realized that I really wanted to get involved in something that provides treatment to patients at a much earlier point, so that they can get it faster. Are there any types of cancers that are closer to being cured than other cancers? Well, I would say that leukemia is one of them, but it's also very expensive because the way that leukemia is, the little story I mentioned, the way it's treated is very specific to patients. So, and then because, remember I said in the beginning that there is the point where you have you get really sick in the beginning, so people have to be monitored during the treatments, so it's very expensive. Hospitals have to have the facilities to monitor the patients, keep the patients there, test them during the whole period. So leukemia is one of them, but it's very expensive. What else? I would say, and I mentioned leukemia because it's a liquid cancer, so basically it's a cancer in your blood, whereas solid cancers are quite hard to get because what happens is they metastasize. Leukemia does too, but solid cancers are metastatic, so meaning that, let's say it starts in your lung, it can metastasize to your liver, meaning the cells in the lungs, even though you treat the lung cancer, it could have changed somehow and moved through your bloodstream into your liver, and now a cancer is in the liver. So solid cancers are pretty hard to treat. I work on a project that works on cancer of the lung, and there's treatments. Cures are kind of rare, but there's treatments that are allowing patients to be cancer-free for long periods. But it's still hard to say cure because they don't know the actual time frame to follow the study to say this person is cured. But there's treatments that, but the lung cancer I mentioned, it is pretty toxic. People get really sick. But either you get sick from the drug or you gets you from the cancer. Most people want to take the chance and get rid of the cancer and just, get rid of the cancer and then let the body recover and be cancer free. So the quick answer was there's some liquid cancers that are curable, but treated early, you can definitely cure cancer. People just don't get treated early. They don't discover it until it's too late. What cancer is transferred genetically, or is it one type of cancer? All cancer in general. It's not one type of cancer. I would say it's more like some cancers. So I'm not sure if you guys know of what is it? BRCA1 gene. So it's related to breast cancer. Okay, so it's related to breast cancer, and again, it is the most famous celebrity that everyone heard of BRCA1 was Angelina Jolie. So she decided to do surgery to remove her breast because she carried the BRCA1 gene. Her mom had cancer, and her predisposition to cancer was high. Doesn't mean she was going to get it, but if she got it and it could spread, it would be really bad. So she took the big step of making the site of where the cancer could occur out of her system. Again, that doesn't mean it's going to be gone, but it was one of the steps she took. So BRCA1 is one of those genes that can be transferred from parent to child, and that can carry cancer. So when you go to the doctors, they usually, I don't know if you kids do it, but when I go to my physical, my doctors always ask me, did any female family member have cancer in your family? Because I'm female, and so they ask those questions. So that's one of the genes. Okay. How can you treat cancer that is caught too late or has moved to other places in the body? Good. Oh wait, sorry, there's another question. How many years did you go to college? What was your college path to get where you are now? Okay. So I went to college for 4 years, but 3 years I kind of bombarded myself because I was tired of college. And I did it 3 years, and then the 4th year I wanted to do the education abroad program, which is what I did. So 4th year I kind of did non-biology work, but I did it because I wanted to see what else was out there. So I did French. So 3 years of college in San Diego. So college was focused on microbiology, and so I liked. Sorry, let me start. I went into college wanting to be a doctor because that's just sort of what they expect: doctor, engineer, or lawyer. So doctor was my career, but I really did not like working with blood, and I wasn't sure I wanted to work with sick people. But I really liked the science. I loved understanding how diseases worked and what caused disease to occur. So in college, I did a faculty mentor program where I worked with a scientist and did small projects. So that was my first lab project. I've never worked in a lab before, and so she taught me exactly what I needed to do, and she was my mentor. And after that, I decided I could do science. I could be a scientist instead of a doctor. So that's how it went through to science. Being a scientist, because initially I was pre-med when I went in. So do you think it is possible with the immunotherapy to completely get stuff? How can you treat cancer that is caught too late? Okay. How can you treat? So when a tumor is really large and a doctor sees a patient that has a huge tumor, basically what they say is first they look to see if there's surgery possible. So if it's large and it's not going to be detrimental to the patient, do surgery. Radiation is another one. They could image and target the cells and kill it. So when it's too large, radiation, surgery, chemotherapy. So what I was talking about, immunotherapy, it also can come into it, but normally when patients go to a doctor, they end up having those main things that I did. They're trying to get to a point where we can do immunotherapy as the first line of treatment because we're seeing it's less toxic. But again, it's hard to, it's slowly progressing. we still need to show that it is better. It's statistically better than using other treatments. So that has to be shown. Do you think it is possible with immunotherapy to completely get rid of cancer in the future? I hope so, but the problem is that cancers are constantly changing. So that means that we have to keep constantly changing the way we treat cancers. There's some that can be cured, but there's more that keep coming up. And this resistance thing that I mentioned, it doesn't stop. It's you see a patient responding, and all of a sudden, and I'm not a doctor, so I never see patients. I'm in the lab setting, so I don't see patients. But what you hear from doctors is that they get treated, and there's a period of when they have no cancer, and then all of a sudden it comes back. So how does that come back? Because somehow the cancer started to resist, or it get run to another part of the body, and now you have to figure out how to treat that part of the body because the cell might be different. So immunotherapy can completely get rid of it, maybe the one that you're treating at the moment, but then something else will happen. How do you all come up with medicine to kill cancer? What is the process of? Have you ever seen real life surgery to remove cancer? I have not, and I think I would gag if I saw it. I am not very good with seeing like blood and anatomy stuff. That's why I can't be a doctor. But how do you come up with medicine? So it's a long process. In our labs, there's many different groups that work on things. So there's groups that work on first discovering targets. So basically, you have a cancer, but you need to go to target that cancer. So there's groups that are trying to look to see what is on that cancer, what is specific about that cancer that's different from other parts of your body that we can target with the drug. Then if that's the case, then you have to look at many different drugs. And there's people develop all types of drugs, and some of them are chemicals. And you have to see if those chemicals respond to those cancers. So you take these cancers that are artificial cells outside in the lab, and you treat to see if the drugs can kill those cancers. If they can, then you take it to the next level where you have to do tests in animal models. So most of the time we use mice for that. So we do different treatments in mice and see how they respond. If the mice respond, then you have a sort of an idea of how to go to the next step. So you still have to do toxicity work, so to make sure that this drug is not going to kill something. So this is when, again, why companies and academic institutes, everybody has to do animal studies, because you have to first check if the drug is working and if the drug is toxic. If the drug is toxic, it doesn't go past that, because people cannot be given that drug. So we always say we have been able to cure mice of cancer. Then into humans, and in humans you still again have to do first toxicity in normal people, and then into actually treatment of patients. And this is a long process, and you have to have all kinds of regulations that you have to follow, and at the end you get a drug. Years of work. So I've been working on I work on I support multiple different drugs that we work on here, and most of the things that I do exactly is to see in these steps, I work in the area where the mouse studies are involved, where we're looking to see if the drug is able to cure cancer in mice. And I don't work with the mice directly, I get the samples from that, and we look to see if the treatments that are given to the mouse that had a response, how did it respond? What kind of things did the mouse have that helped it respond? Hopefully that makes sense then later on when we look at the patients to see if the patients will respond in a similar way. Not a direct comparison, but an idea to make a final decision. Is everybody asleep in the class, or are they actually awake? It's very early. Any other questions? Good, I'm glad they're awake. Very welcome. Well, if you have any other questions, you're more than welcome to email me, and I'll try to answer them. All right. Is that it? Okay, cool, great. Thank you guys. Thank you so much.